All right. Thank you, folks, for coming during this lunchtime. I'm Young Kim, Storage Business Development Manager at AWS, and I'm joined here today for this session by Christy Acosta, who's the Senior Director at SiriusXM, as well as Richard Averett and Luke Adams, CEO and CTO of Digital ReLab. And we're here to go over how these two customers are using Amazon EFS for their media workflows. So here's what we have in store for you today. First, we'll start with an overview of storage at Amazon and a brief overview of Amazon EFS, Elastic File System. Then I'll turn the floor over to Richard at Digital ReLab. Next, we'll have SiriusXM share their story or their journey with Amazon EFS. And then we'll close with some reference material and links to other sessions here at reInvent. And we should have about 5 to 10 minutes for dedicated Q&A. And we can always have individual Q&A here up at the front of the room. So let's get started. So what do you think about when choosing a storage solution? So when you are thinking about selecting storage to use for your applications, well, there's 3 main things that you want to think about. One is, what type of storage makes the most sense for your application? They have different characteristics, different semantics, different interfaces, different permissions models. You also have different features and performance characteristics. And lastly, you want to consider the economics of what you're considering. So let's talk about each of these. Generally, there are 3 types of storage. There's file, block, and object. File storage is data that's stored in files in a directory hierarchy with particular metadata associated with each file. In other words, it's your data stored natively in a file system. When we talk about file in an enterprise context, it's data that can be accessed over the network by multiple clients at the same time. So you can think of it as network-attached storage. In block storage, it's a disk or a set of disks in which data is stored directly as chunks called blocks. And these disks, or a set of disks, are typically connected to a single host. You can think of it as locally attached storage. And lastly, with object storage, data is stored in a container called an object that is identified by a unique key. And it's stored in a flat space, so not a hierarchical directory. And there's a simple API to both get and put data typically over the internet. So why is file storage so popular? First, it works natively with operating systems. So operating systems are designed around file storage. It's the abstraction layer by which operating systems represent their files. It also provides shared access while providing consistency guarantees and locking functionality. So again, shared storage requires multiple clients to be able to access that data. So things like ability to lock out other users from accessing that same file are critical. And lastly, the hierarchical namespace. It's just a simple, logical, and helpful way to organize your data. So let's compare these in terms of, relatively compare these in terms of performance. Block is generally the lowest latency, but doesn't scale to the multiple gigabytes of throughput of both file and object. So it's ideal for applications like databases that are typically running on a single instance or computer and requires the lowest latency. File is designed for low consistent latency, but also can provide multiple gigabytes per second of throughput. And object provides the highest levels of throughput, but it's not really designed for the low latency sensitive applications. So you're all here because you're interested in seeing how file storage can apply to your workloads. And we launched EFS about 1.5 years ago. And before EFS was available, what you had to do if you wanted shared file storage on AWS is do it yourself. So this is typically what we found customers were doing. You would need to set up an EC2 instance with one or more EBS volumes, depending on your capacity. And for high availability, you would need to duplicate that environment in another availability zone. And then you would need to copy the data over into the other availability zone for that redundancy. So you had multiple EC2 instances, multiple EBS volumes, and then you would have to manage the file system layer and data copy. But now we have Elastic File System, which is our native, fully managed file service. When we designed EFS, we designed it with 3 core tenets. Wanted it to be simple, elastic, and scalable, and built upon high availability and durability. So simple, it's fully managed. Again, if you think back to that diagram just a moment ago, all of that complexity, the hardware, the networking, the file layer, is all abstracted in a fully managed service. You can create a file system in seconds, literally just a couple of clicks in the console. Even the pricing is simple, and we'll get to that in a little bit when we cover the economics. In terms of elasticity, file systems grow and shrink automatically as you add or remove files. You know, there's no need to provision at any time, either for performance or capacity. And you only pay for the storage that you use. And in terms of scalability, file systems can grow to petabytes scale. And the throughput scales according to the amount of capacity automatically. And regardless of how large your file systems get, we still provide the low, consistent latency. And a file system can scale out to be accessed by tens, hundreds, even thousands of NFS clients concurrently. It's built upon high availability and durability. Every file system object in Amazon EFS is mirrored across multiple availability zones. So it's designed to sustain any single availability zone offline, which is far superior than traditional NAS or network-attached storage models. So we feel it's appropriate for all production and tier 0 level applications. EFS is also designed to meet a wide range of different workloads, from highly scale-out analytics style and media workflows, all the way to low-latency, metadata-intensive jobs like development tooling and container storage. EFS is able to cover a multitude of these different use cases and applications. Therefore, we have a number of customers in a variety of industries and a variety of use cases using EFS. I'll just touch on a couple of them. A number of customers use us for database backups, primarily because, again, it's a native file option for operating systems. So the databases can mount EFS natively and simply back up as they would through their database tools. Container storage, Netflix and Here Technologies, who in fact did a joint presentation with us on Monday, uses us for container storage. We have a number of customers using us for a variety of different analytics. Monsanto uses us for geospatial analysis. Castora does retail customer behavior analysis. Celgene, another joint presenter, uses us for genomics research. And of course, we're joined here today for media as well as content management by both SiriusXM and Digital ReLab. We offer security at 4 different levels in EFS. We can control network traffic within your VPC using security groups and the network ACLs. We control file and directory access using standard POSIX permissions. We control administrative access to the API, using AWS IAM. And we can encrypt data at rest using keys managed by KMS. You can also access EFS in a few different ways. One is by multiple EC2 instances within your VPC. You can also mount EFS from on-premises hosts in your data center over Direct Connect. And we are also happy to announce that you can also use EFS as shared storage for any applications running on and in the VMware cloud on AWS. So a little bit more about EFS economics. There are no upfront commitments or fees to use EFS. There is no need to ever provision storage or hardware in advance. And there are no other billing dimensions. The only thing that you pay for is the amount of capacity that you store. Okay. And those are the prices in the various regions where EFS is available today. So when you think of the costs of do-it-yourself, where you would have to set up this environment to be comparable to what EFS provides, you had the EC2 costs, you have the multiple EBS costs, as well as inter-AZ data transfer costs to have copies of that data across different availability zones. And when you add it all up, in this example, for 500 gigabytes, EFS is over 70% less expensive than do-it-yourself. And that's just on the infrastructure pieces, not including the additional management and administration that you would have to perform in that environment. Where is EFS today? So it's currently available in 6 regions, as indicated there, and we have a lot of regions on the roadmap. If you have any particular regions you're interested in, you can come see me at the front of the room. So with EFS now, when you think back to the 3 major categories of storage, EFS completes the storage portfolio at AWS. So now we have block, file, and object in a couple of forms. So you can really choose the right storage or different types of storage for your different applications. On the left, we have a number of different data movement tools to get data both in and out of our storage services. And they are integrated with the various other services for security and management on the right. In particular, last week, we announced EFS File Sync. So this feature is a very simple, fast, and secure way to copy data into and out of EFS. So you can use EFS File Sync to copy data from on-premises hosts into EFS, from other in-cloud file systems into EFS, or between EFS file systems, even across AWS regions. All right. So with that introduction, I'd like to turn the floor over to Richard Averett, CEO of Digital ReLab.
Thank you so much.
Sure.
All right, so let's start with a really short video.
You're dealing with much subtler issues, cultural issues.
President Trump's first 100 days have captivated the world. Attention sat down with Bill Maher for an exclusive interview.
So there's a quote that I love by Don Miguel Ruiz, and it is that every human is an artist. And the main art that we have is the creation of our story. And by the way, this includes all of you and all of us, right? We're all artists in our own lives. And one of the things that we love about technology is how specific the development of software is truly a creative and artistic process. So the short video you just saw is a quick sample of some of our clients who are all craving the same thing, the opportunity to tell their story in the ways they want, faster, more efficiently, more eloquently. And so what gets in the way? Well, how many of you can admit to spending hours or even a day hunting and pecking for a photograph or a PowerPoint presentation or a PDF or a particular video that you're looking for? And when you find it, you're then strapped with these other questions. Is it the original? Is it the highest resolution? Where else have I used it? What are my rights around it? I mean, let's face it, most of our content is truly trapped deep inside our folders, or stuck worse on hard drives that are disconnected and on shelves, or my favorite is now in the endlessly scrolling sidebar of Slack, right? And you know you have it, but you just can't see it. And even compounding that is that in the moment that you're looking for it or find it, you still have this problem of answering that information. Like, what is it that I'm allowed to do with it? And that is often in an entirely different system, equally obtuse. So Carl Jung once wrote that the creation of something new is not accomplished by the intellect, but by the play instinct, acting from inner necessity. And the creative mind plays with the objects it loves. So accessibility, play, and playback, these are the essential requirements for creating in a media-driven world. And they're very much the core of the things that we focus on at Digital ReLab. Amazon and AWS give us the technological infrastructure to create playgrounds in which our clients can play and create the stories that they wish to tell, truly at unprecedented scale. So my name is Richard Averett. I'm the co-founder and CEO of Digital ReLab, and I've got the great pleasure of being here with Luke Adams, our CTO today, to share with you sort of how we're using AWS and EFS to help leverage this opportunity for our clients to achieve their creative pursuits and support our business needs. So, who are we? At Digital ReLab, we're painters, we're archaeologists, we're musicians, and we're technologists. And what you're looking at here is a picture of the recording studio in which Digital ReLab was born. My partner and our visionary behind our software, Peter, owns this recording studio in rural Virginia. And he launched what has become Digital ReLab by trying to make it easier for himself to create, assemble, remix, and distribute digital media from this studio. And in 2012, Peter had the opportunity to meet with Jeff Rosen of the Bob Dylan Music Company, and he was blown away to realize that Jeff had really the exact same problems, just at a much larger scale. So here he was sitting on one of the most valuable and iconic archives in our history, and yet he really had no meaningful way to access that content and pursue new creative opportunities. So Peter set out to build a software solution that would unlock the hidden assets of the Bob Dylan archive. Now, full disclosure, Dylan is not in the cloud. They were patient number one for us. They're in an on-prem solution that Luke's going to describe. But in 2015, I joined Peter to explore how broadly this solution that he'd built for Bob Dylan might be repurposed and used and to create a truly scalable business model. So we hit the road. And for 9 months, we traveled around meeting with companies as big as the largest ad agencies in the world and as small as a single professional photographer. And the discovery that we had was that every creative person or team basically said they were desperate for a new solution that allowed them to work more natively, more creatively. Interestingly, in most cases where there was an IT department, which is not all of them, typically the IT department said, hey, we've got software for this. This problem is solved. So what that told us was that there was a real disconnect, and the conventional wisdom and solutions actually were failing the very people who were now in charge of the most valuable commodity in any creative business, and that was the content. And we also learned something most of you will know, which is that the fidelity and the frequency with which all companies are creating this rich media was truly exploding like the Big Bang. And it's not just true for creative industries, right? We saw the same things in manufacturing and in insurance and, of course, in healthcare. I mean, the COO of Airbnb recently said that managing video is one of the biggest challenges for his company in the coming years. So both the size of the files and the sheer magnitude or number of them is expanding and accelerating at the same time. And with pretty much no exception, true solutions that will scale with this must be in the cloud. All right, so this is a tech crowd and a tech talk, and I'm going to get way out of my pay grade if I stay up here. So I'm going to turn it over to our CTO, Luke Adams, and he's going to explain to you, dive deeper into our decision to go with Amazon Web Services and how we're leveraging EFS in particular to solve our client needs and meet our business needs. Luke?
Thank you, Richard. So as Richard just said, we have incredibly creative clients. We often work with emerging media companies that are experiencing an explosion of content creation and the need to scale with that demand both from a storage perspective as well as a transformation perspective. These clients require that we not only keep pace with their growth, but we also meet the expectations to leverage the latest tools and services for improved efficiencies in media intelligence. As a small team, it's important that we use our resources as smartly as possible and when implementing new technologies. We work really hard to concentrate our efforts on effectively evolving our platform and to meet current and future demands and use strangler patterns to incrementally improve and replace components. So as Richard said, Starchive started as an on-premise solution for Bob Dylan. And this is at a high level of the architecture. It's a lamp stack, something we're all probably in this room familiar with. We would go to where the content is, on some drive or multiple drives. We would mount those file systems that were POSIX-based, and then we would ingest the data with our data discovery and transformation tool. We would use open source tools on top of Linux, such as FFmpeg, ImageMagick, XFtool, among others, and gather the intrinsic data of the files as well as create new types of metadata and store that in a relational data store. We would then take the transformed files, either from transcoding or otherwise, and store them in a content repository, which is, again, a POSIX-based mount. And then we serve this content up both from a web interface and an API with Apache. So there's a lot good with this. It's very well known. It still runs a good bit of the internet and workloads that we see across the world today. And it's very well supported with a lot of open source tools and knowledge. It scales vertically pretty well to handle large workloads. And deployments are very well known, and there's a lot of tools such as Ansible, Puppet, otherwise, and AWS tools as well to deploy and manage that infrastructure. But scaling can get expensive and intrusive, especially when we're working in an on-prem solution. And really, often from a scaling perspective, we often size them for transformation, but we're not always doing transformation. We have lulls in transformation, and we often have wasted compute cycles when just serving content. So we knew we wanted to go to the cloud. We knew we had to go to the cloud to have a viable product and reach more customers. So what we did is look for approaches that would simplify this journey for us. And we partnered with AWS to do that. And when we started, EFS wasn't actually even available. But we used EBS, which is a POSIX-based file system and works perfectly with our system. And we also deployed RDS for better scale and management of our data. And we also saw the addition of another first-class content repository with S3, where we could lower our storage costs. So this was, again, another seamless transformation for us into the cloud. We did have to update some of our deployment playbooks with Ansible, but there was not really a whole lot of work there to do. We gained less management of the infrastructure with some of the managed services, and we lowered the cost for storage. And we also have now a package that we can deploy via AWS Marketplace, which we're going to be doing in 2018 to reach, again, more clients. But we still have a lot of the same scaling issues that we do on-prem. At least in our architecture and our application, it was honed to a single client. So we would scale it vertically to meet demand, but again, during lulls of transformation, we would have wasted compute. So closer to where we are today, and really kind of the role EFS has played in allowing us to not scale horizontally, but not scale vertically, but scale certain aspects of our stack horizontally. And it also allowed us to take, with the savings from a management and infrastructure perspective, and focus on going and gathering data from new places, cloud providers, and otherwise, to reach more kinds of content. So here we see basically EFS being used now as our primary content staging area, and our ability then to take and scale horizontally compute nodes to handle that. And I'll talk a little bit in a minute about how we can actually scale that transformation compute based on not only the amount of data we have within the file system, but also the type of data that we might have at any given time. We still use RDS, we still use S3 for content repository, and we also introduced Glacier, or are introducing Glacier, to push assets down to a lower cost for some of our clients for those less accessed assets. We also use EFS to help support our web assets. So we have an easier, it makes it much easier to deploy software to our clients, as well as manage session state across the cluster of Apache instances. So there's a lot of gains here for us. One is that this was really a relatively easy transition from us, all the way from on-prem to a horizontal scaling platform, using really the exact same code base. We had to update some of our deployment scripts and our Ansible playbooks, but that's very well supported. And really, we now have the virtually unlimited capacity to stage content and scale out our transformation as needed to handle that. So there are challenges with implementing any new technologies, but really EFS is NFS, so it's something that we're familiar with. It was something that we could natively use inside of our architecture. But we had to also understand a little bit about the capacity limits and the ways that in which we can use EFS, and I'll talk a little bit about that in a minute. And we're also still have room for improvement. We've heard a lot about serverless here at reInvent this year, and we're looking for ways to implement new types of architecture for both transformation and content delivery. So a little bit of a background on kind of the content we see across all of our Starchives. And those numbers are a little bit maybe hard to see, but 75% of what we have is images. And that number is a little bit skewed in that we create images for everything we have because we're a visual platform. So no matter if it's a video or a document or an image that may be raw and large in capacity, we're going to create derivatives that are playable in a web interface and distributable across the web. And what this also talks to is our ability to also scale, again, based on the type of content we have. FFmpeg is an absolutely wonderful tool for transformation and probing of video files, among other things. And we know it works very well in a multi-threaded environment. But images, for instance, or documents with tools like ImageMagick that are single-threaded can use different types of compute instances that have better cost efficiencies. So the chart on the right talks a little bit to the savings that we saw. And with this chart, the interesting piece is that from our perspective, or from our journey, that there's actually more savings in not over-provisioning compute than there is in the actual storage costs themselves. And in our case, that was around 43% based on what we were saving against EBS. So we continue to try to take that savings and look for new ways to advance our product, again, being a small team, using our resources as wisely as possible. So the way we save on our end, as well as pass that on to the customer, is having less idle compute times, again, scaling the cluster down to near zero under lulls of transformation. Our ability to take our on-prem stack and get it into the cloud very quickly, as well as maintain parity with our existing on-prem and new clients that might want an on-prem solution. We used our existing DevOps Ansible playbooks to continue to deploy, and we could reuse all of that work. And we can take now and focus that on new products and clients. So what are some of the things that we learned in our journey with EFS? One is that, as I mentioned before, it is NFS. It's something that we're familiar with, but there are some things that within the EFS capacity limits that you need to be aware of, and you can easily monitor that with CloudWatch dashboards and metrics. And some of the things that you might run into is putting small loads of content into EFS and then kind of trying to process that quickly and running out of burst credits. So what you can do is basically move in temporary storage for a small period of time to give you the capacity and then remove that. Now, we realize that's kind of a hack, but the way we treat EFS is that it's really a transient file system, and that we load as much data that we can into it based on our incoming content providers, but we work hard and scale compute to get it off and get it into lower cost storage. be aware of thrashing the file system, and maybe this is just automated scripts or systems engineers that aren't familiar with some of the capacity limits. But if you have a large number of files within folders, just be aware that you might use up some of your I/O if you're running different types of commands on that. And like really any NFS file system, use configuration management, identity management, or some way to keep your compute instance maintaining user IDs and group IDs across all of your NFS clients or EFS clients. Multiple file systems, in our case, does a couple things. We can provision EFS file systems that have higher compute than others. There's a couple different ways to provision those, as well as separation of concerns. So we don't want to host our web assets on the same file system that we're doing transformation. So if we have high levels of transformation at a given time, we don't want that to affect any of our web runtimes. So I mentioned that we're moving forward with serverless architecture in new ways, and we still see EFS playing a big role in that. So we're not just serverless, we are also doing kind of microarchitecture with containers, and Lens is a product that we started to scratch our own itch about 6 months ago, because we deal a lot with S3, and we're visual people, and we wanted to better visualize what we had. So basically we created Lens, which is a product that allows you to probe everything in a bucket and create a visual representation, collect metadata with the same tools that I mentioned that we were using in Starchive, as well as recognition and some of other tools to give you AI-based metadata. And then we put that into a beautiful user interface to allow you just to visually scroll through your files. So here's a little bit of a glance of what the Lens architecture looks like. Again, it's S3 first as far as where we go for the storage. And then we deploy AWS Batch to pull the files out of S3. So no matter if we're working with millions or hundreds of millions of files, that we can have long-running runtimes to support that. And EFS helps us manage configuration and state across those Docker instances. We then use Kinesis and some of the data pipelining tools that are available now in Lambda to take that data and move it into DynamoDB. As things are added into DynamoDB, we send them off again via Kinesis for transformation. We have a one-to-many as far as our streams and our shards to how many transformations we might deploy against that. And we can do that either with Lambda functions for things like recognition, or if we have longer-running processes, we can deploy Docker containers backed with AWS Batch backed by EFS. We take the result of that, bring it back into Dynamo, and then send it out to Elasticsearch for the web interface and API to consume. So to highlight here again, AWS Batch is being supported by EFS, as well as our thumbnail clusters that generate all images dynamically and caches them inside of an EFS store. So I'm going to bring Richard back up, and he's going to talk a little bit about a client that we have that is actually using both of Starchive and Lens.
Thank you, Luke. So let me give you one specific client story. One of our newest clients is Attention, and you may or may not know them. They are social impact content, millennium-focused. They produce mostly all short form, sort of 3 to 5 minutes, and predominantly on Facebook today. But they're doing about 500 million video views a month, so quite a following. And because of that, they're now getting a lot of opportunity to produce sponsored content and longer form content. So today, Attention produces about 12 episodic pieces a month, and they have demand to go to 18 or more, plus this longer form content. And for every one of their 3-minute videos that they produce, they have as much as 20 hours of unpublished, high-quality video content you might refer to as B-roll. And so they're nearing about 0.5 petabyte, which by this conference standards is not a ton, but for a small company is significant. But more importantly, they're creating 2 to 8 terabytes of new content every day. And as they scale with these new opportunities, that's likely to double. So they have got 2 goals out of the gate. The first one is to deliver these 2 to 8 terabytes of dailies, migrate them into the cloud, and have them ingested, transcoded, augmented with new data, and available the next morning. So that by itself is not a small task. Secondly, all of that unused footage that's taking up space on their drives, they want to move all that available, all that B-roll, and that's going to be made available for the Attention team to use, but also for licensing and other revenue-generating opportunities. So over the past 6 months, leveraging AWS, we've made it possible for Attention to make use of all of their available data during ingest, to create new data or media intelligence with AI tools, and more of those are planned in the future. We've automated a significant part of their workflow, and we're enabling great search and easy distribution of the B-roll. So EFS has made it possible for us to utilize our existing tech stack, as Luke said, and move quickly to support a client like Attention. Very different from our use case with Bob Dylan, obviously, but not have to be concerned about provisioning new storage for that transformation. EFS is clearly key to our strategy to speed up our time to market. So why does it all matter? Why do we care, right? In short, content often gets described as assets, even when it's really inaccessible. And we like to debunk that. We really don't believe that media or data sitting in disconnected drives in various disparate storage environments are assets. In fact, in pure economic terms, they're liabilities, right? But leveraging AWS, this is our content journey. We're going to help you take those liabilities as raw content and make them accessible to answer that question, where is it and what is it? We're going to add data to answer the question, is it the original? Is it the highest resolution? What are my rights around it? And then we're going to augment that data with AI and other analysis tools like recognition to discover and surface insights into the ever-expanding content collection so that every new piece of content that is added is now instantly related to the other assets by any of its shared tags or properties or business data that matters to you. And think of that as future-proofing a catalog for small but powerful content owners to leverage their content and be able to compete with the biggest players in the market. EFS and AWS provide the ability for us to focus on the problems that these clients want to solve and trust that the infrastructure is built to grow and evolve no matter what those client demands are. So, Anthony Gaudi is famous for saying that the creation of, creation continues creativity continues through the creation and the media of man. And it is because of this that we get up every day. It's the thing that excites us. And so we are super excited to be partnering with AWS. And we know that tools like EFS will continue to be key components of helping us make some of the most valuable collections in the world available and accessible first to their owners and eventually to all of us. So with that, thank you very much. And we'll bring up Chris Acosta. This guy's serious.
Good job. Good job. So, I'm Chris Acosta. I manage the streaming infrastructure for SiriusXM, and that is why we're here, why we're talking about EFS, is the streaming aspect of SiriusXM. But I want to, what do we do? What does SiriusXM do? Most of you probably know we are a satellite radio provider, and our content, we have about 150 satellite channels that we have in our satellite channels for our streaming infrastructure, or for our satellite infrastructure, and we have about $5 billion in revenue for our company, and it's 32 million subscribers that we actually have. So it's a pretty impressive amount of subscribers. But what you may not know is that we also have other aspects, data services. In data services, we have weather, we have sports scores, stock prices, and electric vehicle charging stations. So we're kind of a green company. We want to make sure that you know where to charge your electric vehicle. Also, new to our portfolio is a company that we purchased and now own, Automatic.com. They have a plug-and-play kind of telematics infrastructure that basically you use a port that's been in the car, native in the car since 1996, and it tracks your trips, it reads the computer codes in your car, and tells you your gas mileage and your driving habits. So if you're an aggressive driver, like I sometimes am, the app will tell you that you're being a little bit too aggressive. It also gives you crash alerts. As far as our traditional telematics infrastructure, we have a built into many OEMs, we have a telematics provider, much like you get to unlock your doors if you lock your keys in your car, or gives you location, gives you onboard diagnostics, crash detection, and call center assistance. So if you're ever in trouble, you can reach out to them, and that they'll tell you, they'll try to help you out. But why we're here today, why we're here discussing EFS, is in the streaming division where I work. We have a streaming infrastructure. It's been growing quite a bit. Our clients, our main clients that we use are iOS, Android, and web. But we also have home devices, and that's mainly why we're here today talking about EFS, is a home device that we recently launched and had some issues with. So 400 channels as opposed to 150 in streaming. And who's listening? So we have subscribers. We're a subscription-based service. And the devices, the amount of devices that actually can play back our content are really the key to being able to provide subscribers options so that it's available. We would love to have our content out on as many devices as possible in order to entice subscribers. So we have competition. There's other people that have streaming devices, but there's also WIIFM. And when you consider our executive management, our programming, our marketing department, product management, and engineering, a lot of them have to worry about what's in it for me. Essentially, what happens is time can steal from all these people's time, and the focus gets lost. So we're all competing against not only your time when you go to listen to a choice, but we're also competing with our own time. So everybody's listening to that radio station. Our problem that we had to solve was we were about to launch a home product. This home product was baked. The client was done, the back-end system, the streaming API was done, and then we did a load test. And the load test, it failed. It failed miserably. So we were in a situation where we had a client that had to launch in 3 months, and now we were presented with a problem. We had a client that couldn't handle the load. So we had a choice. We needed to have a fast, reliable distributed data store, and we needed it quickly. And we had some problems. Client application was finished, as I mentioned. Our content or cookie management is key in our implementation. And our client that we were dealing with can't eat cookies. So we had a choice, obstacle or opportunity. And we never like to say no, but 3 months is an aggressive time schedule to be able to solve this problem, to handle load. So our challenges, time, absolutely. 3 months, again, not a lot of time. Security is baked into everything that we do anymore. It's a horrible world out there. Hackers are always getting into various areas. You hear about it all the time. So security for us is taken very seriously, which adds complexity and time to your schedule. And then, again, minimal, if no, client changes, and minimal, if none, API changes. We had to deal with that. We had to have reliability, 5 nines, not really possible with an internet application, but we strive for that. And then we needed a distributed architecture. So for us, distributed architecture is pretty essential because we're in North America for our streaming services. You can listen outside of North America, but our subscriptions are North American based only. So when you're doing software, you can either do fast, cheap, good, and you can pick 2. In our case, fast was inevitable. We had to deal with fast. And as far as cheap, we didn't have time to do cheap. We had to be good because we had this application. Product management was saying we need it. Upper management's thinking it's going to launch, and all of a sudden we have these problems. But we also had to consider some things beforehand because there's not a complete cloud culture in SiriusXM. Do we want to do it on premise? Have to ask that question. Well, we ask it, but in engineering, when it comes to these types of problems, we pretty much didn't even consider it. We know our infrastructure, we know what's going to be fast, so we didn't even consider it. And did we consider another cloud provider? Given our background in Amazon, we've been in Amazon since 2011, It just honestly wasn't, it was a non-starter for us. We went right to Amazon. But so we picked fast and good. We had to look at Amazon's tool chest. What could be a solution? Now, by the time we found this out and we started to investigate what tools to consider, people were already doing their investigation. They were looking at what could be the solution. Earlier, Yang pointed out that you could build it yourself. You could build an EFS-like infrastructure yourself. But configuration, that is a time killer. That's something we couldn't afford as far as building it ourselves. We looked at other things within AWS that might fit the bill, but we ended up choosing EFS because of the infrastructure benefits, the scalability benefits, that sort of thing. And we noticed and read documentation, Amazon's documentation is really good. We noticed that it was very easy to mount. It's a great system as far as easily mountable. It goes, it integrates with many things. And one of my requirements going to the engineers was, look, this has got to be launched in 3 months. It can't be developed and then we start testing, or developing and we start beta testing. It had to be in 3 months. So the fact that it was in AWS, could be integrated into our CloudFormation scripts, gave us, just confirmed our decision to do this from the beginning. Had to have integrity, because a lot of what we're doing with EFS, the integrity is key, and the distribution of the information had to be NFS-like, which when I heard what EFS was like, as far as being NFS-like, it gave me pause because of my experience with NFS in the past. But the distribution and the way that it's been implemented with EFS in AWS actually eased my mind when I learned about it. Plus, it's scalable. As most things are within AWS, the scalability just works for us as far as when we increase and are successful with subscriber growth, we need more. We need to be able to scale more. And we've grown, streaming has grown 35% since the beginning of the year. So it's a fantastic thing. So when we chose this, we sat back and we had this NFS-like instrumentation to be able to manage our infrastructure as far as what was missing. So in our case, we solved the deadline problem by 3 months. Cradle to grave, we launched on time, was great. Scalability, it just comes when when you launch the number of volumes or file systems that you want. We can scale horizontally with file systems all day long. They're easily communicate with each other across AZs, as Yang mentioned earlier. And the construction, I mentioned the CloudFormation script. Ability to integrate this into our CloudFormation scripts. It's CloudFormationable, that's a word I made up. And the infrastructure, it all gelled, it really worked together. It made us look like heroes given where we were in the development of this proxy-like solution. So when we launched, we looked back and we said, wow, we did a post-mortem. We had to make some improvements. There was definitely improvements that were made because an aggressive timeline, developers, when they were working through the solution, it wasn't optimal. We definitely had to tweak some things in our implementation of our solution. But we ignored cost up front. And when we revisited our solution, we realized that our costs weren't there. It was cheap. And our implementation was, very rushed. 3 months is not a lot of time to be able to solve the problem that we did solve. So it's very inexpensive, but you have to, in the lessons learned slide here, you'll see you have to understand what you're getting into when you look at EFS. Its configuration can be a challenge. So here's our architecture. This is kind of talking about the solution of what we did. So with architecture, there's really two hemispheres of this architecture. There's the actual proxy, because it's really a proxy that's sitting in front of the home device. And the home device that's shown there isn't actually the home device we solved this for. That's Alexa. We launched our Alexa app earlier this year successfully. It was announced, big hoopla, and Alexa actually became our either number one or number two streaming home device a week after it was launched. So many people were very happy about that, and it didn't hurt that it was launched on Howard Stern's show. So with these two hemispheres, these two areas of the infrastructure, you can see there's an Amazon Route 53 DNS entry just for this client. So you see the VPC, the security groups around all of the components within that VPC. We're using RDS to manage sessions, because we have session state. We're not free. And we use EFS for cookie management. The cookie management is earlier, Luke mentioned thrashing. Well, these are very small files that are being written in and out, grabbed to and from EFS. So there is thrashing. We knew that was going to be the case. And that's where the configuration that I'll get to really paid off. But you'll notice also that we have two EFS file systems there. The reason is because we were very concerned about I/O. Our I/O definitely took a hit when we first started the implementation. We noticed that we weren't responding as quick as the system that actually failed in the first place. And it wasn't necessarily because of EFS, it was because of the implementation and not being able to get to the information. That's why we have two EFS file systems mounted there. And then there's the back-end system. This is the streaming API. It's not a real detailed picture, but essentially that proxy stood in front of and communicated to the streaming API that the web client, the mobile clients talk to, other home devices talk to, and then there's on-prem access from the VPC out there. So when we look back and we look at lessons learned, you have to know your throughput limits. EFS is horizontally scalable. You can stand up multiple EFS file systems within your infrastructure. And for us, that was the lesson I talked about earlier, was you need to make sure that you understand what your limits are as far as throughput. Throughput's key for us because you're talking about a person that presses, I want to listen, whatever the home device is, and they want to hear their content. So for us, that was key to being able to make sure this was a successful launch, and was probably one of the things that really scared us at the end, was the fact that we weren't getting the throughput that we wanted. And then the burst speeds, or burst credits. Luke mentioned this earlier. It's definitely something that we saw after we launched. It's not something that, it sneaks up on you. Burst credits, you probably need to read the documentation as far as how to tweak burst credits, because it depends on your file use, how big your files are, how quickly you need to update them. And burst credits are something that's, you probably need a PhD in to figure out, but I'm sure that's not necessarily what Amazon wants to hear. So as far as load testing, we did not really have an effective load test in the beginning. We were using JMeter to test the previous version, and we broke it. But with respect to the later solution, we started to use those JMeter scripts and ramp up instances in AWS to really slam this thing. So if there's one lesson I can give you, is when you're using EFS, load test your implementation. It's key, because it will point out the issue or issues that you're going to be dealing with. And then, obviously, Luke mentioned this also, and I would recommend this for any implementation in AWS at all, is your monitoring. We didn't have enough information when we first launched to know what to monitor, what was going to break. So for us, CloudWatch, we were learning and implementing CloudWatch as we go. And to be honest with you, we're still, this home product just launched not long ago. We're still learning and tweaking those CloudWatch monitoring tools to make sure that we're getting alerted so that we know there's a problem. Because a lot of times we're caught, we're caught without knowing why is it down. The last thing you want to do is get your boss's boss calling you saying and you can fill in the rest. So with that, I want to thank you for paying attention to me, and I'm going to turn it back over. Well, actually, I'll give Yang the clicker here. Thank you.
Thank you, folks. Thank you, Chris. And my AWS business card also doubles as a burst credit card. So if you need more burst credits, feel free to come see me. Just real quick, I want to close with some additional references as follow-on materials. So if you want to know any more about Amazon EFS, this is your starting point, our EFS portal. Here you'll find blogs, white papers, reference architectures, a TCO calculator, as well as tutorials and documentation. There are other opportunities here this week at reInvent to learn more about EFS. We are now in the middle of these. So if you'd like to understand more about the underlying technology around the lessons learned that our customers shared, there is a repeat of the deep dive session where they get into the technical details much more tomorrow at this time. And lastly, I'm also excited to announce that there's new storage training. So again, got to pick the right storage for your workloads. So we're introducing a number of different training options for you folks to get deeper knowledge in the various storage that we offer. Okay. So with that, we do have about 4 minutes for some Q&A. Feel free to raise your hand and we can pass a mic as needed. I'd like to call up the presenters to help with the A portion, as well as a couple of other folks. So Kevin Satterley from SiriusXM and Nate Casey from Digital ReLab.
If there are any questions.
If, yes.
Right, Cameron, question?
When you said horizontally scalable, did you manually shard your data across multiple file systems, or was that one file system that you evaluated?
So currently we can do both, but right now we're within one file system. But as capacity is needed, you can use two, and we'll use CloudWatch metrics to help us determine both load on the file system to trigger that scaling.
So you look at like percent IO.
Correct, and we also do some level of interrogation of the data itself to understand how we want to scale. Sorry, I had a hard time hearing that.
Basically, you host the media file sample, right? So how do you preview the files? My customers are across the globe.
So from our perspective, I understand the question is how do we preview the files when they're on EFS? So the media files. So Starchive and Lens itself takes that raw data, and we often work with ProRes, very high resolution, large files. And part of our transformation pipeline, when we're moving the files, or using EFS even as a temp space often, the result of that transformation, the files get stored down in S3, and we create derivatives based on configuration. So you can create 720p or files that are appropriate for distribution, and then they are becoming available within the application. So we don't necessarily preview them while we're in EFS, but we do monitor what kind of files and what their size are to correctly scale compute.
Sure.
So in your guys' pipeline, you store your data in S3, pull it out into EFS to do your transcoding, and then shut it back in S3?
There are some situations, like if we deploy Snowball for a client and the data will come into S3, that will move it into EFS for temporary processing. But the majority of our data is coming in from a host of places, and EFS is the first place it lands. And that gives us kind of a huge ability to scale the amount of storage that we can stage for transformation.
But then long term, you're
That's correct. And then we'll move both the original and any derivatives that are created from that into S3, and then push some of that down into Glacier as needed based on utilization of the files or client requests for lifecycle.
What's stopping you from keeping all that in
Well, I mean, one of the things that is nice about S3 is it is protocol based. It's built for the web, and the way we distribute is on the web. So we have a really an easy way to distribute it. And there is a lower cost of storage long term in S3 as well.
That's like figuring your bucket to be exported
Yeah, so I mean, we have a front to that. We proxy all incoming requests and how we actually distribute. We're not necessarily passing out directly S3 links. We deploy Lambdas and API services to do short-term signed S3 URLs for distribution and a number of layers there. But anything that we're going to distribute, we would stage in S3 for distribution. I think that's all the time we have.
All right.
Thank you.
Great.
Thank you.
Thank you all. Enjoy the rest of re:Invent.